Okay, there we go. Yes, so, one thing you'll note is remember last time how these were protected? Same with up here. They were protected. I changed them to private. They were protected originally, I think, because I was expecting to do some fancy inheritance thing that I never actually did, so it's not relevant. So yeah, just to reiterate, this comparable. If something extends comparable, that is a way that Java then can guarantee that the thing of type T, if it extends comparable, then I know there is some ordering to them. And if you go look Java 17 comparable, there's a lot of stuff going on in here. You can read the actual documentation. This interface imposes a total ordering on the objects of each class that implements it. This ordering is referred to as the class's natural ordering, and the class's compare-to method is referred to the natural comparison method. Blah, 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 blah. If you write any class and you make it extend comparable, then you must implement this compare-to method for your class. If your compare-to method exists, what it will do is it'll say negative some number if x comes before y, positive some number if x comes after y, and 0 if they are equal. Okay, so this is the idea. If you extend comparable and write this compare-to method, then we can guarantee that that object has some sort of ordering. We are going to see an example of this, I think, once we get to binary search trees, I want to say. Let's see. Binary nodes. Let me have a quick look to see if I actually have an example of that later. Because the big point right now is not understanding the ins and outs of comparable and compare-to. That's not what's important right now. The important thing is the idea that the thing of type T has to have some ordering if we're putting it in a sorted list. Because otherwise, if there's no ordering, well, sorting's not a thing. Like if I gave you a bunch of blades of grass and said, sort these, you're going to say, what? How? By color? By size? By mass? I don't know, right? So you have to tell it, okay, here's how you compare these blades of grass. All right, let's linked binary search tree. So T extends comparable node. Does anything in here have, let's see if I have a, do I have a compare to? Contents are identical. Okay, I don't know what I'm looking at right now because the screen's too small. Hide. Linked binary search tree compared to. What? Okay. Compare to. Let's try this again. Convert compare to expression to equals. No. All right, so it doesn't look like I have an example of it being used here, but whatever. It's a thing. You can find a million. And we'll talk about that a little later. So back to the stuff. All right, we're not talking about that right now. Okay, array bag. Okay, so yeah, the things in our sorted bag have to be comparable in some way. This is going to look a heck of a lot like our array stacks constructors. Okay, here we're talking about comparable. Oh, look at that. And I even got a link to Java comparable. Cool. Returns negative if y is less than, cool. Oh, I may have had these backwards then. Returns negative if y is less than x. I can never remember the ordering. Let's assume this is correct. If not, we can test this later. All right, when we have something extend comparable, yada, yada. Okay. Finally, we have this. This is a wild card. If our type T does not extend comparable and we have a compare to method within it, that might be fine as long as it's, yeah, okay. We talked about this last time. Any questions about this? Because I don't want this to be a can't see the forest through the trees scenario where this isn't that important right now. What this means is the thing of type T has to extend comparable, meaning there must be some order. And then this right here, really it means that, well, it doesn't even need to be the thing of type T extends comparable. It's that like a superclass of T can be comparable, meaning like I inherited it from something that's already comparable. All right. What does comparable look for? Like, I don't get that part. It means that, here we go. Look, perfect, perfect. Here's an example of it being used. How do we identify comparable? So you're not gonna be identifying comparable. Okay, the only time you're gonna need this is if you are making your own class that you want to have some sort of ordering. Here, you know what? Let's do a quick example. This might be a good time to do a little example. If we go to our friend class, actually here, I'm gonna go to not this one, lecture stuff, friend, all right? This friend class does not extend comparable. If I try to put friend objects in an array sorted bag, it's not gonna work because it's gonna be like, how do you sort these things? How do you wanna sort these things? So what I can say is, no, trust me, it is sortable. And here's why. I'm going to write a compare to mean now you have a way to compare things. So extends comparable of type T, but it needs to be of itself. So now it's going to be mad because implements comparable. Maybe it's implements I need. Implement methods, yes, compare to, great. So I'm implementing comparable, and I'm going to compare these objects, okay? So I get some object of type O. I'm just gonna, for the sake of what we're doing right now, I'm just gonna dump this. Does this need to be, can this be a friend? Friend must either be declared abstract. Yeah, okay. I'm gonna do all this. Okay, compare to return. Friend. Why is it mad about overriding? Method does not override method in the superclass. It must be object. Okay. Okay, so. Yes, it does now. Oh, because this needs to be object. Pardon me. All right, so first I'm going to cast the object to a friend. If it's not castable, then this is going to throw an exception, which is good because it's no good. So how do we want to sort these friends? We are now the ones saying, here's what the order is of the friends. How do we want to sort them? By last name? What do we say? We have each friend object has 3 fields: first name, last name, and email. How do we want to sort them? First name. Great. We want to sort them based on the first name. Now, the good news here is I can actually, and this will happen a lot of times, I can actually hijack the strings compare to. The string method already has a compare to within it. The string class, pardon me. So if I click this, string, look, it's comparable. Implements comparable, string. I probably need to add friend to that. So yeah, it's comparable. So compare to, here's our compare to. Great. So we have our compare to right here. This is the strings compare to. It's like alphabetical. There's a couple asterisks to what I just said. It's gonna sort it like alphabetically. So I can just hijack the friends and say, okay, return this dot first name dot compare to friends first name. There. I just wrote my friends compare to. Now this extends comparable. This should be friend. And then this should be friend. There. So there, great. In fact, I don't need to do this anymore either. I'm going to change this to that. There. So here is our compare to for our friend class. We're just going to hijack the strings compare to and let it do all the work for us. Great. Now, because this class implements comparable, I now know that we can throw these in our array sorted bag. What will be returned? Well, it'll just return the result of this, and this does all this fancy stuff right here. Basically, a negative number if one's less than the other, 0 if they're equal, and a positive number if the other is bigger than the you know. So it's just a negative number, 0, or a positive number, depending on what comes first. How is the name less than a name, though? Alphabetically. That's going to be like it's like lexicographical sorting. Java lexicographic order. So let's see if I can find. Let's get rid of the Java and see if we can just find like a wiki page. Here we go. Lexicographic ordering. In mathematics, a lexicographic or lexicographical order, also known as lexical order or dictionary order, is a generalization of the alphabetical order of the dictionaries to sequences of words. Okay, so of course they're making it sound super complicated. Just, you could think of it alphabetical ordering. So the strings already are aware, like the strings can already be sorted alphabetically with compare to. That's how they are sorted. So I just did that. And if you're thinking, well, what if you want to write your own? Okay, fine. Here's what we'll do. How about if this dot first name dot length plus this dot last name dot length plus this dot email dot length is greater than that dot first name dot length plus that dot last name dot length plus that dot email dot length. Okay. So if that's the case, we'll return here. I'm going to do it like this. There. So now I have it this length and that length. Now I can never remember which one's which, so if I get the order wrong here, don't put down your pitchforks. But I think it's always like, it's a negative number if this one comes first. So I could be like, if this dot length is less than that, oh, not this dot length. This length is less than that length. Then we will return -1. Else if this length is greater than that length, return +1 or 1. Else return 0. Great. So here's our compare to now. There. If this comes first, so based on this, what is the ordering I have defined for this silly, like what is the silly ordering I've defined? If the total length of their first name plus their last name plus their email, that is the order. The total length of those 3 fields. Is that a good ordering? No, it's a stupid ordering, but it is what it is, right? Why? Because I could write it. I am defining what it means, like what the ordering is for these objects. One thing you'll notice actually is what you'll actually notice is I can do this. return this length minus, oops, that length. This will actually do everything for me. If this length, let's say this length is 10 and this length is 15. So this one's smaller. So what's 10 minus 15? Well, that's -5, negative number. If this is 20 and this is 15, 20 minus 15, well, that's +5. Well, that means it's a positive number. If they're equal, well, then it's 0. So this right here is an actual easier way to do the compare to, just an FYI. They don't need to be -1 or +1. They can be any negative number, any positive number. So now, because this implements comparable, I can add these to my array sorted bag. Cool. Your hand is cramping just watching this. What? I don't understand. What? All right. Okay. I'm gonna get rid of this though, because it's silly. It's nonsense. My brain be cramped. When you were typing out the this dot and that's okay. Yeah. All right. Back to lecture stuff. Okay. Here. Not friend, not that. Oop, I gotta switch to main. Ooh, actually, I have a, there's been an update. Someone is now, let's take a moment. And everyone, we have a new contributor. Ya boy Adam16. Everyone should give him a nice applause. Here, clap. There you go. Well done, everybody. There you go. So we have a new contributor. Awesome. Maybe what I will do is whoever contributes the most or something. I don't know. A prize or something like this. I don't know. I'll have to think of something. What about me? You mean all of these contributions? So other contributors are 97X. They're in the course. Okay. They also have a YouTube channel. Or wait, what is this? Hypno is in the course as well. I think only those people that are those are those from the course that have made contributions. So, well done. 479 commits. Comments. What? Click it. Click the YouTube link. No, not right now. Not later. Later. If I contribute the most by the end of the year, will you buy me a Snickers bar? Deal. Whoever contributes the most. And contributing the most does not necessarily mean if you... It'll tell you like, oh, I've added 29,000 and that's many. 3 and 3, 1 and 1. Like, this isn't what contributing will... This is not how contributing will be calculated. It'll be up to my discretion on what has been done. But whoever contributes the most, I will buy them a Snickers bar. If I continue by the end of the year, buy me stickers. I gotta be a jumbo Snickers bar. All right, fine. Fine. Automatic pass? Well, if you're contributing a lot to GitHub, all right, fine. Whoever contributes the most to GitHub will pass the course. But you still have to finish all the content and work hard. So issues do not get added to contributing. You have to do PRs, pull requests. All right, I gotta get back to course content though. I'm glad you're all keen on this, but course content. Okay, adding method. All right, close, 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 and then array sorted bag. Great. Expand capacity, that's not new. Shift left, we have our shift left. This is the same as the array index bag. Shift left is we removed something from the middle, I guess, and we need to move everything down to fill that gap. Shift right. We want to add something in the middle, so we have to make room. Shift right. Sentinel index of, we already went over this. The fancy word sentinel means, okay, it's going to return a special value. So index of is doing a linear search to find the index of a given thing. If it doesn't find it, we return not found, which is -1. If we go up to here, -1. And you might say, why not just say -1 instead of using a constant? You're right, but I don't know. What's more meaningful to you? Return not found or return -1? Well, you could probably figure out what the -1 is, but this is very obvious, right? So constants are another good... People think of constants as like, well, that's only if you want something that doesn't change. Well, yeah, but constants are also a great way to give something a name, right? It's like a variable, but you know it's not really like a variable. So it's just some constant. Int find insert index. Okay, so here's the idea. Find insert index of an element. I want to add something. So this is basically add. Are we recording? Yes, we are recording. So when you say, I'll edit that part out. Right. I lost my train of thought here. Okay, so private. It's a private method, but find index of. This is basically going to be the magic of our add. Because if we go look at our add, I say, okay, if we need to expand capacity, magically find where it needs to be inserted, magically find the insert index, shift right, add that thing, increase size. Or rear, but rear is size. But of course, this makes use of this method. So what is this find insert index? Okay. T element. So I'm doing a linear search, but unlike the linear search where I'm going like, oh, okay, see if this thing exists. I'm doing a linear search to say, where does this belong, right? Like if I have the number 55 and my list in my bag goes like 40, 50, 60, well, I need to know that like it basically goes where the 60 is and we got to move the 60 down to make room for it. So that's what we're going to do here. So I've got this search index here. I heard a boop. What is the colon symbol for? This is like the fancy loop. I can do this with a regular old for loop. I could say for int I equals 0, I is less than blah, 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 blah. But like we were talking last time, this is kind of like the for each that we were used to in Python. So this would be like for each bag element in this thing, where this thing is this collection, and this collection is basically like the bag. So that's what this means. The colon means like in. But of course this is Java, so we have to actually specify the type. The type is type T. This, we use colon instead of in. That's all. So for each bag element in this thing, in this class, or in this instance of this class, if the element dot compare to bag element less than or equal to 0, basically, if I ever find where the element belongs, okay, I'm gonna keep going, right? So this right here, this if statement is what ends this method, right? So I'm gonna keep looking at each bag element until I find a bag element that is, I guess, bigger or equivalent to the thing I want to insert. Okay? Would I be in the compare to? What I would say is I would have to say like bag at index I. So I could do it something like for I, there, I is, I guess, rear, I plus plus, I think rear. And then I would say if bag at index I would do element dot compare to bag at index I. And then what's this mad about? Oh, and then I would need like the less than or there. And then I could just return I instead. But I did it with the fancy iterator, which that's next topic, I believe. So back to what we've got here. There, okay, for each thing, keep looking until we find where it belongs. Return the index. If we don't find it, increase search index. And if we ever get to the end and don't find where it belongs, well, then we just return the rear because, like, that means it must have been bigger than everything else currently in the bag. So it just goes to the end. So that's find insert index. It's the magic private method that we use for add. And I really want to emphasize, this really comes with experience. But you might say, why did you think to make this a private method? You know, why not just, like, basically take this, copy, and just replace this whole method call with something like this, right? And you're right. There's nothing saying I need to make this a private method. There's nothing saying that I shouldn't have the code from this private method within add, right? There's nothing saying that that shouldn't be there. But, I don't know, you look at this and you think like, see, this add method, when I look at this, it's really clear. It's short, it's clean, but it's only short because by virtue of like, oh, it uses find insert index and it uses shift right. So it and it might call expand capacity. So there's 3 private methods it might make use of here, all of which could have been thrown into this add method. There's nothing saying I couldn't do that, but look how clean this is. If the size is the bag length, expand capacity. Great. How do you do that? Well, we go to expand capacity, right? Look at where, there it is, right? So all of the code from expand capacity, shift right, find insert index could be in here, and we could exclude these method calls. But then this method would be really long. This method would be pushing like a lot of lines. And there's nothing wrong with that. That's not bad. Or that's not incorrect, but this is nice and clean. You could be someone who doesn't really know that much about Java, but maybe you know a bunch about programming, or maybe not even that much, but you go like, okay, if size is equal to length of the bag, expand capacity. Find where it goes, shift right, add the thing in the index. Oh, okay. Like this is nice, succinct, and clear. How would you know what to make a private method and what not to? Why not make this a private method? You know what? I don't know. Why not? But why not add this to another method, right? Why didn't you put the if the size is greater than this, throw to expand capacity? I don't know. There's nothing. The only way you get a sense of what should and shouldn't be in private helper methods is through experience. And, you know, there's nothing wrong with the private helper methods. And same thing here. Is it better to have code like that where you pretty much don't even need comments? So, in general, there is a big argument. There are some jobs, there are some companies where they say you're not allowed to comment your code. Because if you need to comment your code, that means your code is too complex or too complicated. See, your code is too complicated. So we don't like that. You need to write your code in such a way that it needs to be obvious what it's doing. Now, that sometimes is wishful thinking, but the spirit of what they're saying is pretty interesting. The spirit is like, well, if you wrote your code really nice and clean, you probably don't need a lot of comments to explain what's going on, right? Like, you're experienced enough with Java that there's not a single comment here, right? But you probably don't need it. And you know what? Shift right could probably have a better name. I could be like, this maybe could be called like make room. And shift left, maybe that should be like close gap. That maybe those are better words to use here. I don't know. But this is really self-explanatory code. Now, to your question, don't go crazy trying to have your code simple. Okay? At this stage, you're still all fairly new at this, right? And writing nice, clean, beautiful code is something that comes with a lot of experience. So if you're working on your assignments and you find a nice, good way to make your code nice and clean and simple looking, great. But if you're really struggling, but you've got it working, but you don't know how to clean it up, that's not a priority of yours. There's no marks associated with like how clean is your code, you know, other than like, okay, comments and variable names and whatnot. But this right here, there's no comments. In fact, you'll see like there's no comments in any of these. And that's not because I was lazy, but it's because like, well, it's all fairly straightforward. Let's keep going. What is style we get marked for? That would be things like your comments plus your method names plus your variable names and following conventions and whatnot. That's kind of a catch-all for like, you know. And by this stage, I don't think we'd take marks off, but the following would be poor style. And you still see it every once in a while. Like, for example, this right here will return true or false, right? If size is equal to the bag, it either is or is not. So this will be true or false. But sometimes you'll see people do something like, okay, if it's true, right? Well, this is not good because if the size is equal to the length of the bag and this is evaluated to true, and if this thing that evaluated to true is equal to true, well, true is always true. So the result of if true is equal to true is true. If this is false, well, this is false. And is false equal to true? No, that's false. So this is useless. And even IntelliJ is trying to warn you about this. Like, hey, this can be simplified. Yes, simplify it. So that could be bad style. Would you ever give the rubric with the assignment so you can check to see if we have everything to not lose easy points? No way, Jose. The descriptions should be good. Because the only thing with like ambiguity, like, I don't know, with the way that the assignments are supposed to be designed are, if there was any ambiguity in the assignment description, that's a problem on my end and I can like fix that. But some, like, what I don't want to do, because if I start saying things like, oh, did you do this one little thing and not lose marks? It might give you part of the answer. Like if I say, write a method to do X, Y, Z, and you wrote a method to do X, Y, Z, but you didn't catch edge cases, like the funny, like, well, what happens if it's size 0? What happens if it's size 99? You know, whatever. If I say like, oh, did they check the edge? Did they check the edge case where it was 0? That kind of tells you like, oh, I need to do that. And that's kind of taking away the point of you solving these problems. Like it kind of might give away some of the problems. So I know where you're coming from, but yeah. But again, if like the last assignment, this was an obvious example. In the last assignments, people were like, I lost marks for not doing this method about population density. Yeah, I messed up. That was supposed to be in the assignment. I didn't put it in there. Y'all lost marks for that. Okay, clearly that was a mistake. So we fixed that. If there's anything else kind of like in this next assignment too, where it's like, hey, you know, everyone lost marks for this thing and you never explained it, we'll figure that one out. Because it usually becomes really obvious. If everyone makes the same mistake, maybe the problem was with me and not with everyone else. Sometimes it's with everyone else, but usually. I'm going to get back to the course content. Adding method. Okay, so we've got our add. Let's look at remove. All right, if it's empty, well, we can't remove first from an empty bag. Otherwise, get the thing from index 0, shift left all the way to 0, rear minus minus. Return the element. Remove last. Well, if it's empty, you can't. Otherwise, rear minus 1. Bag, rear minus 1, set it to null, rear minus minus, return element. Great. Some people might say, hey, no. if you do rear minus minus first, you decrease rear, then you do that, then you do that, and you don't need that. Isn't that better? Yeah, sure. Sure, like yes, like that absolutely is fine. But I don't know, I kind of like it this way because to me it's like, okay, well, I always know rear is the next open spot. And I'm kind of going with that logic where it's like, well, that's the next open spot. So the one before it is the one I'm returning. There. Okay, and after all that, okay, decrease rear, so now it's the next open spot. Where if I decrease it first, it's like, one's not better than the other. It's just, I like it this way. If you want to fight me on like, hey, no, this should be first. You should do this up here so you don't need the minus ones because it's cleaner. I will not engage with you on that fight because yeah, sure, there's nothing wrong with doing it this way. I just kind of like it this way because to me it makes more sense this way. Why? It's even hard to articulate. I just kind of like it this way. A lot of, programming and computer science is a lot of math. Like programming is math, whether you like it or not. We've tricked you into doing a lot of very sophisticated mathematics. But because it's like math, people expect it to be like, well, it's right or it's wrong. But you'll see that with things like this, we're like, well, should that have been first or last? There's a lot that's up for debate where it's like, there's not a right or wrong answer here. There's a lot more like essay writing in this type of math than a lot of the math you're used to. Oh, it's either right or wrong. Well, it's kind of not quite like that. True. How wouldn't that return the second from the rear? I didn't sign up for 2 calc classes. Well, it's not calculus at least. How would that not return? Because if I do rear, let's say there are 10 things in the bag. That means rear is 10, right? If rear is currently at 10, if I do rear minus minus, okay, let's do this one first. Rear is 10. The next available spot is index 10 because 0 through 9 are full. 9 is the one that actually contains the last thing. So I say rear minus 1, so 10 minus 1 is 9. Makes sense. 10 minus 1, well, that's 9, set it to null. Then we decrease rear to 9, and then we return the element. And we decrease rear to 9 because we removed it. So now there's not 10 things in there, there's 9 things. 0 through 8 are full. If we do it this way, rear minus minus, we say, okay, rear, you're now 9. Now, bag at index 9, that's the thing we want to return. Bag at index rear, you're now null. And return element there. So we set it to 9 first, and then we don't need to decrease anymore. That's all. Yeah, remember, it's just like the stack, right? So with the stack, like rear is the next available spot. Stack, top is the next available spot. And we did that because of zero-based indexing. I mean, this isn't why, but one of the benefits of this is if there are 10 things in my array, I could, like, that 10th spot is actually the open one because 0 through 9 are full. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 in total because we count the zeros, right? Wait, where'd my finger go? Yeah. So yeah, rear is always empty. That's the idea. It's the empty spot. It's the next available spot. Remove any general element. Okay, well, if it's empty, no such element. Okay, removing from an empty bag. Otherwise, do the index of the element. If it's not found, throw an exception, right? So we do the sentinel index of. If we get not found, well, it's not there, so we can't return it. Otherwise, get the thing we want to remove from return element. Or assign it to return element. Shift left, close that gap. Set rear minus minus. And then return the return element. In fact, I want to have a quick look at my shift left and shift right. Yes, okay, I did set the last thing to null. Good. So that was our general remove. And by the way, at any point, if you have questions, stop me here. Remove. Okay, great. First, if it's empty, there's nothing there. Otherwise, return bag at 0. Last, same idea, but the last one contains. So this one's easy. We're just going to hijack sentinel index of, and then if it returns not found, well, then it's not there. If it doesn't return not found, well, then it's there. Get count. This is a linear search, but instead we're doing a count for each bag element. If it's equal to the target, add it to the count. So this would be like, if I've got a bag of a bunch of numbers, and I'm like, well, how many 17s are in there? Well, I'll go through and count the number of 17s. Is empty, size, iterator, this magic return new array iterator, or what? String, that's R2 string, using a string builder. But notice that this toString is a little different than the two strings we saw before. Do I have it in here? Okay, I do not. So this toString is a little different from what we've seen before. If we go look at array stack, where's my toString? I used a for loop with a I 0, I is less than top. And if I look at the linked stack, and we go to our toString, I used a while loop, and I would be like, well, okay, while the current node is not null. But with the array sorted bag, I've switched it up a bit. I've switched it to use this other for loop. That's just like, okay, for each thing in the collection of things, for each bag element in this bag, take the bag element, append it to the builder, whatever. This is an array. So there's no for loop with for I, and then I'm not indexing the bag at index I or anything. No, this for loop here is just giving me each individual bag element, which is really neat. And this is enabled because we implemented Iterator. Up here, implements, oh no. Oh, because we have the Iterator, pardon me. Because this thing, where is it? Iterate. Yeah, because we have an iterator for this class. So if I had an iterator for a linked version of this, I can write an iterator as well. But the iterator would have to work a little differently. So the mechanics of how this little iterator class does its things will be a little differently. But if I have an iterator for a linked structure, I can still use a for loop just like this. So it would enable me to write my toString with the exact same code if it was an array one or a linked one, because I can just loop over the contents of that collection with the iterator, regardless of what the underlying collection is. This is all being foreshadowing for next, iterators. Which we obviously don't have time to get to today, but often we like to access every element in some thing. An array, a stack, a queue, a bag, whatever. And we call this iterating over that thing. And we've done this countless of times already with arrays, just like this. For int I equals 0, I is less than some array.length, I plus I. And then some process, some array on index I. And we also had it with the while loops, with the linked structure, but instead we can use iterators, and we will pick up this tomorrow. What is the string below in the comments? All right, nah, I think we could bits through it today. Sorry, I don't think we can, but R2T2, the commented out one is using an iterator a slightly different way, where you say it.hasNext, but we're not doing it that way. We're doing it an even better way, but we'll learn all about this for the next tomorrow. Oh, where's my head? Any last questions before we wrap up? All right, well, either way, I'm going to stop the recording.